This is my presentation for week 5 of my AI class, explaining genetic algorithm terms and relating them to their closest counterpart in reinforcement learning. So the first term is individual, and an individual in genetic algorithm refers to one of the, I guess, one of the things that are actually performing the task. And then in reinforcement learning, that's the agent. And there's only one agent in reinforcement learning, but with genetic algorithms there can be multiple individuals. And then next is the search space, which is where the individual is actually operating at. Like, for example, a security guard is patrolling the mall. The mall is their search space. And then in reinforcement learning, that's just like the environment, which is like the same exact thing. And then the selection strategy um, is when the individual decides if they are going to exploit or explore. So they pick, and that's their strategy. If they're going to explore, that's the strategy. And then selection. This is the actual. This is when they use what they know to get better at solving their problem. And then in reinforcement learning, that's like exploitation. So using like if you know the quicker path already, you'll start taking that. And then for mutation, this is like the exploration factor in reinforcement learning. It's like a randomly, where you randomly gain an attribute in hopes of that helping you solve the problem better. And then breeding. In genetic algorithms, breeding is whenever you take two individuals with good scores and combine them in hopes of achieving a better score. There's no breeding in reinforcement learning because it's just the one agent. Up next is the fitness function, and this will determine if the individual gets a higher score or not. So if there's a goal position that the individual needs to get to at the end of every run or whatever, they would get assigned a point based on how close they are to the goal position. And then the fitness score, this is the actual score that is determined by the fitness function. So this gets ran, and then they're given the fitness score. For reinforcement learning, this is just like the reward system and then the actual reward. And the reward, I mean, it literally almost means the same exact thing. The better you do, the better reward you get. The worse you do, you lose reward. And then population. In genetic algorithms, there is multiple individuals who are trying to solve the problem. So that's referred to as the whole population whenever there's multiple of them. And in reinforcement learning, there's just one agent, so the population is almost always one. And then crossover. This is whenever they take two individuals and cross them over in hopes that they can achieve a better score in their next run. This is like the main thing with genetic algorithms, breeding and crossing over and combining the individuals. And then a gene is one specific byte of data that the individual holds. So whenever they're crossover, the genes that provided better results, the genes that got the individual closer to the goal, will get combined with the genes from another individual that helped get it closer to the goal. And the genotype is the combination of all the genes that make the solution. And then the highest peak is the best possible solution that the individuals can achieve in their environment. In reinforcement learning, it's the same. I mean, there is a highest peak, I guess, because everything has a goal. Like in reinforcement learning, when you meet your goal, you've reached the highest peak. For genotype, gene, and crossover, there's really no equivalent in reinforcement learning. All right, thank you.